My name is Narjas Nixon. I'm a postdoc researcher at Cone University of Applied Sciences. In this video, I will provide you a brief overview of our paper titled ConvGenVisMo, Evaluation of Conversational Generative Vision Models. Conversational generative vision models like Visual ChatGPT are obtained from the combination of a trained conversation model with a trained vision model. It is important to analyze their performance to a suitable evaluation framework on realistic datasets. In this study, we developed two ideas. First, we curate a new benchmark dataset for conversational generative vision model evaluation. Second, ConvGenVisMo provides a suite of several existing and new evaluation metrics to assess the performance of conversational generative vision models. ConvGenVisMo datasets contains 180 samples. Each sample contains an image and a conversation between two real users about that image. Only one user has access to the image and is explaining its content to the second user, who doesn't have access to the image. The dataset provides 6 categories of images. These categories allow a range of conversational topics. This is the overview of conversational generative vision model evaluation process. For each conversation sample in ConvGenVisMo dataset, we generate a summary of the conversation up to each hop using ChatGPT. Then, for each summary, we generate an image using Dream Studio. Finally, the generated images are compared with the ground truth image using the evaluation metrics. In this paper, we explore several existing metrics like computational full reference image quality assessment metrics like PSNR and semantic full reference image quality assessment metric like clip score. These metrics have limitations in accurately considering the presence of specific objects in the images. Therefore, there is a need for evaluation metrics that specifically measure the presence of elements or objects in the generated images. So we capture this notation with element presence scores. Furthermore, we introduce the concept of @k for each evaluation metric. Finally, clip score and element presence scores do not consider the location of the elements in the generated images. So we use IOU scores, which take into account both the size and the location of the objects. The findings indicate that the computational full reference scores may not be reliable options for evaluating the step-by-step improvement in generated images for each hop. On the other hand, semantic full reference measurements prove to be valuable in evaluating the enhancement of generated images as the number of hops increases. Additionally, element presence score play a critical role in evaluating the generated images in terms of presence of desired elements or objects. The dataset and the evaluation codes are available on our GitHub. If you have any questions, please feel free to email us. Thanks for your attention.